You might think this forest is silent, completely still as the morning mist drifts through the canopy, but if you were to listen, not with your ears, but with a different kind of sense, you'd find it's anything but quiet, beneath the blanket of leaves and the tangle of branches. A conversation is unfolding, a dialogue that has been happening for millions of years. It's a language spoken not in words, but in whispers of chemistry and electrical impulses, a secret world hidden right under our feet. Let's dive beneath the surface, into the rich, dark soil. An incredible network thrives. These are not just roots. They are conduits of information. Look closer. See those fine, white threads? That's mycelium, the vegetative part of a fungus. These fungal threads form what scientists have dubbed the Wood Wide Web, an intricate, subterranean internet connecting the trees. Through this network, they don't just absorb nutrients. They communicate. A mother tree can send sugars to its struggling saplings, nurturing them through the shade. A tree under attack can send out a chemical distress signal, a warning to its neighbors to raise their defenses. They share resources, warn of danger, and support their kin. It's a complex, cooperative society. A forest family bound together by these hidden fungal threads. And it's not just the trees that are part of this conversation. The animals are listening in. They are eavesdroppers on this ancient botanical language. When a tree is being munched on by insects, it doesn't suffer in silence. It releases volatile organic compounds into the air, an aromatic alarm call. Suddenly, a deer nearby lifts its head, its sensitive nose catching a whiff of this warning. It knows that this chemical signal might mean the plant is becoming less palatable, or that danger is present. Small birds perched in the branches react to these invisible signals, altering their foraging patterns. They've learned that a tree sending out distress calls often means a feast of insects is nearby. These animals are tuned into the forest's frequency, interpreting messages that are completely invisible to us. They aren't just living in the forest. They are active participants in its dynamic, ever-shifting dialogue. Their survival depending on their ability to interpret these silent broadcasts. This creates a fascinating ripple effect, a chain reaction of behavior that cascades through the entire ecosystem. Imagine this: a giraffe starts to graze on an acacia tree. The tree immediately begins to pump bitter-tasting tannins into its leaves to deter the herbivore. But it does more than that. It also releases ethylene gas into the air, a warning signal to other acacia trees in the vicinity. The downwind trees receive this message and start producing tannins in their own leaves before the giraffe even gets to them. The giraffe, finding its meal increasingly unappetizing, moves on. But the signal also attracts other players. Predatory insects might be drawn in by these chemical cries for help, arriving to prey on the very bugs attacking the tree. Birds, in turn, notice this congregation of insects and swoop in for an easy meal. One single act of a tree being grazed sets off a complex, interconnected series of events that influences insect behavior, bird feeding patterns, and even the movements of large herbivores. It's not a simple one-to-one interaction. It's a symphony of cause and effect, where one note played by a plant can change the entire composition of the forest's activity. For centuries, we walked through these forests, utterly oblivious to the complex social drama unfolding beneath our feet, and all around us, we saw trees as solitary, competing individuals, fighting for sunlight and water. The idea of them communicating, of cooperating, seemed like something out of a fantasy novel. But in recent decades, pioneering scientists like Suzanne Simard began to unravel this mystery. Using isotopic tracers, they were able to follow the flow of carbon and nutrients between trees, proving that they were indeed sharing resources through their fungal networks. Now, with advanced sensors, researchers are placing electrodes on roots and trunks, measuring the faint electrical pulses that travel through the trees, much like nerve impulses in our own bodies. They are deciphering the chemical vocabulary used to warn of drought, disease, and pests. We are finally beginning to understand that the forest is not just a collection of plants, but a highly integrated, intelligent system, as alive and social as any animal community on the planet. So, the forest thinks, it learns, it remembers. When you watch a time lapse of a forest through the seasons, You're not just seeing random growth and decay, you're witnessing a coordinated, collective intelligence at work. The forest as a whole responds to changing light, to the length of days, to the memory of past droughts or fires. It adjusts its growth, manages its resources, and orchestrates the comings and goings of the animals that depend on it. This isn't chaos. It's a beautifully choreographed dance of communication and adaptation. The forest is a superorganism, a living, breathing entity that processes information and makes decisions for the collective good, ensuring its own resilience and survival over millennia. It's a mind far older and perhaps far wiser than our own. So, the next time you take a walk through the woods, take a moment, stop, and just be present. Feel the ground beneath your feet. Listen to the rustle of the leaves. Remember that you are not just an observer. You are walking through a vast, ancient network of life. You are in the presence of a conversation that has been going on since long before we existed. And as you stand there in the quiet stillness, remember you're being watched. And maybe, just maybe, spoken to. Thank you so much for joining us on this journey into the secret life of trees. If you found this as fascinating as we do, don't forget to like, subscribe, and hit that notification bell so you don't miss our next exploration into the wonders of the natural world.